Gledamo prvo predavanje, z nami bo Kristjan Donat ob 9:31.
Good. Welcome to the session Product Placement 4.0, Chances of Digitalization for Product Manufacturers. My name is Kristjan Donat. I'm a German civil engineer. I tell you a little bit about my background and why I'm talking to you about this issue. I had worked 10 years for a construction company, Hochtief, in international construction. I got more and more dragged into research and development, and that happened to become more and more sustainability. Was not called sustainability then. I took over the position of the CEO in the founding phase of the DGNB, the German Sustainable Building Council, and was CEO founding the DGNB system, represented Germany in the World Green Building Council on the board in the years of my CEO-ness for DGNB. Since 10 years now, I'm self-employed, helping manufacturers to communicate towards sustainable building. You know that there are a lot of issues on sustainability, and there's a lot of data being communicated, and that is more and more digital now. So I'm helping the manufacturers to digitize and digitalize. And this is how I got more and more into this issue of product placement via digital tools. And I know that digitalization is a challenge for manufacturers. And this is mainly due to one reason. Many different applications and tools have different requirements on data sets, on data format, and even content. And manufacturers are on a daily basis confronted with new applications that require new formats, new kind of data, new data sets. Of course, this means an enormous high level of effort. These many applications which happen to develop out there and continue to develop all require their own formats, as I said, and it costs a lot of effort to generate all these specific data sets that are needed, and that is actually not necessary because the content is more and more always the same. So there's a certain level of metadata, but the different formats and the different collections of the data require a lot of effort. Going along with the high effort, you have a loss of control at most manufacturers that we see, because the manufacturers do not have the competences and the capacities to produce all these data sets themselves. So they delegate it to external experts, and they lose control about how the data is generated, about in what databases their data is actually uploaded to. And they tend to decide for just some of the applications because they can't deliver to all of these applications and databases, and not for all of their products, because that's just incredibly high amount of effort, which is not possible to deliver to. This goes along, not to mention, with costs for the data generation, for fees, for external services, and these costs are never ending. As there are updates required. And of course, when you delegate services, then you tend to lose the know-how if you ever had it. But you have here a field of a very crucial know-how on your data, product data, in a digital way, which is used in simulations, in design tools. So it's even functional data. And you need this know-how. And if you lose the know-how, you have a liability issue as well, because you remain responsible for the data as manufacturer. And even if the data generation was delegated to experts, you never know whether they perform well, or whether your data is correct, whether it's up to date, wherever it is. And if architects are taking or other users are taking the information about your products from data sources which are not directly under your control, they may face liability issues as well. In many cases, we have seen that manufacturers even lost their data ownership to database providers or external IT supporters when they signed the agreement with them, the general terms and conditions agreements. So that is something which is relevant for manufacturers. Keep the ownership of your own data. It is clear that if you have a lot of sources for data, if data is stored in databases, various databases and tools, then you just have to wait for discrepancies, errors, out-of-date data, and this is all creating risk and additional work. So now we talked about all the negative aspects of digitalization, but of course, it's not just bringing risk and effort. Many of these applications, which we will take a look at what I mean with applications and tools when I mention it, offer great opportunities to place your products. The first step that you need to do is you need to manage your own data pool. That's something which prepares you for future and for responding to the demand and to deliver. The idea is that you create an own meta database. We call this a BIM database. For sure, you have your own IT architecture in your own companies, and this BIM database is communicating inside your organization. Maybe you already have a PIM or an ERP system. Then, of course, it needs to be connected and communicating with each other so that you don't have data redundancies inside. No problem. The BIM database, as we call it, this metadata pool, is collecting all the information that is needed to be shared with the outer world and outer applications. So you have one source for all applications and tools from the outside that need product data or product related data from your products. The data inside the metadata pool gets optimized for digital use. This is very important. It needs to be modular and clean so that you can from there connect to via API to relevant platforms and relevant tools directly. And the data can even get generated on demand. So you build the data sets with an automatic tool, we call it file generator, specifically designed for a specific application. And if you want, a user can define the content for the file, or an application can allow configuration of your products, which is extremely important. If you have a lot of variations of your product, the user will need the specific building element or product and not a list of possibilities, which leaves the user with all the liability again, or requires a lot of know-how how to put the information together, which product goes with which color or texture, for example. Building up a structure like that, you avoid redundancies and obsolete data, of course, because the data source is always your own data pool. It's connected live, it's uploading live. The generation of files goes live. I can show you something live later on of one of the examples from our client, Rockwool. You remain the data ownership, and you have a lot of opportunities to track the user data. So instead of leaving other databases do the user tracking and then selling back the information for your marketing on what the preferences of the users for which products and which applications they click in what order, you have the data on your own, under your own control, and can use it. It's valuable data, I can tell. And most important, we all don't know what applications and requirements will develop in the next years and how the situation will look like in 5 or 10 years. But what we know is that with a flexible structure like this one, you are future-proof. You can control your data, and that remains actual as you manage it. And the connection to the applications is then just programmed with an API and a file generator. So it is very easy to adjust your database or adapt the data to future requirements. Talking a little bit about how the world looks like from the perspective of an architect. How is an architect or other users are actually using your data? What do they need? Very simple element here, just a wall which got created in, let's say, Revit, and the architect gave the wall a certain geometry. Now, what the architect would like to have is a Revit file, a Revit family, which applies the necessary information to this wall so that the architect does not have to build up the wall himself, because there's a lot he doesn't know, he doesn't have the information for, and so on. So he just downloads a Revit file for a certain building element, applies it via drag and drop, and it is as simple as that. And then afterwards, you have a building element which consists of data. Now, of course, we're talking about geometry. You have a geometry, the width and the height of the wall. Well, that is something which was given to the wall in the application, like in Revit here or ArchiCAD or so. But you have a lot of more information. Geometry can mean, of course, the width of the layers, and that information was given here, as well as all the material properties of the components. This can, of course, be a single element, like the stone wool. This is a rock wool example. But that could be generic data of other elements, building elements, or even system component partners, specific information of the bricks or mortar, and so on. So the material properties are given with the BIM data set as well, same as names. Of course, all products have names, and graphical information, which is so necessary to communicate and have a photorealistic, or the possibility of photorealistic rendering. You need colors, you need textures, bumping maps, reflection maps, and so on. This all can be given together with a product if needed, if wanted by the user. Ingredients could be communicated if you want. You can, of course, avoid that. Documents can be attached, such as data sheets or calculation reports, tender text elements, photos, videos, what you want. You can attach it to the file, and of course links as well. So you can link back to your own database, to your own configurator for a specific element. And if a designer had decided for downloading a building element in a certain level of detail, LOD 200, a lower, earlier design stage detail grade, then later on he can link back, or another designer in the same project could link back to the database and upgrade the element to maybe LOD 500. And that is all possible from your own source. So you already understand that product placement via applications can offer a lot. If talking about product placement, we often think, first of all, about virtual showrooms. Of course, you can deliver with this very same data structure to virtual showrooms as well. You can deliver the data needed. We are talking mainly about BIM applications here and today. And first of all, let's start with rendering. A good rendering should always be part of this. A good rendering sells. It's sexy to have a nice optics, a nice view, and architects know that. So they prefer data which has good visual information, which they can use in their own powerful rendering machines. So the data should be optimized for that. The digital design tools, the BIM tools, allow a lot. We are again here in the Revit example, to stick to one of the applications. Of course, there are many others like ArchiCAD, for example. And you have the IFC format to exchange data in between different tools. We're talking about generation of all these and delivering data to all these different tools. Now, take a look a little bit more into BIM. I don't want to tell you all the things that you already know, but some facts which are necessary here to understand what we are talking about. BIM projects on a project level do not keep what they promise at the moment. I think we all know that. That has reasons. BIM is not mainstreamed yet. BIM is not sufficiently standardized. And often, you know, the product data for BIM is just missing, or the data which is there is not really effective for use. It was made up by architects who do not know about information for facility management applications or something like that. So it offers a lot more opportunity, and then it gets used. BIM is much more than 3D geometry, we know that. So BIM files can contain numerous kinds of information on products, and BIM files can be used here as a universal data carrier. Now, using the possibility of generating these BIM files automatically on demand, we have the solution which could fill the gap, and it could help BIM to work properly on a project level throughout all the dimensions. If architects are forced to look for BIM data at the moment in order not to create it and generate it on their own, they usually go to some databases, product databases, such as, for example, here, BIM Object. There are many out of there. Or they go via a plugin in their design tool. We again have the example of Revit, and there are plugins, and maybe the database that they're preferring has offered a plugin. But the databases are not complete, they cost money, they require updates, the data is not fit for use, really. It is not offering all the variables, so not all the specifications of products that you would need. We asked users in a very big study together with some of our clients, where do you actually download your BIM files? And the outcome was, in all of the countries, more than you see here on the picture, in all the countries, the manufacturer's website was where they actually downloaded the files that they were using. You see that the totals of the percentage sum up to more than 100%, and that has a reason, because architects used to look for information somewhere, like in a database, but then they go back to the manufacturer's website to get their variation, their configuration, or just to be sure that the information they got from the database will be not out of date, so for liability reasons. So this is why they come back to the manufacturer's website, and here starts your big chance to offer solutions for configuration that you can again in future connect them with the web tools and databases and applications. And I would like to go with you in an example from Rockwool, where we created for different opcos, so the different companies in the different regions, different tools. This is an example from Rockwool UK, and you see that Rockwool UK is thinking about different problems. So think from the demand side, think from the user's perspective. A user, like an architect, has a problem of a U-value to be solved, or an acoustical problem, or maybe a fire protection problem, and they are not looking for a product in the logic of the producer. So let's say we're an architect, and we're now live on the database here, by the way, and we're looking for a U-value calculator. If we are an architect, then probably we need to deliver a roof or a wall or a floor. Let's say we need a wall with a certain U-value. And of course, we know what kind of construction we are thinking about. Let's say we have a brick wall, a masonry cavity wall, and we don't need to fill it full. We have just a partial fill in there. We need some airspace, and we do it with a medium dense block in olive. The outside finish is a brick. That's what should be visible, and on the inside we have maybe a plaster, just a simple plaster. Now the system is asking us for our U-value, and we know that what do we want? Maybe 0.18 is what we need to deliver. And now if we click now on details, then the actual calculation is done. The data sets get generated from the database, so the data file generators operated, and now you have the detailed structure, and you have download results, and you can decide what to download. The Revit file, the IFC file, the U-value report, the acoustic calculation, this is added value. And then you can apply that to your product in the logic which I had shown earlier. So this is how future configurations look like. There are many other examples of different applications and configurations. You can tell that you can learn a lot about the user preferences, how they click, when they click to what. So this is what we see as the big advantage of the future. And of course, implicit is a change from the product level to a building element level. You don't need to do that, but this is at least possible with in a quite simple way. And then, these are the last two ideas that I would like to share with you, because before allowing your questions to come, of course you could create professional visualizations in 3D, which are for sure much more comprehensive than 2D cut sections, not only for the B2C communication, but as well in a B2B communication to installers. If you can tell them, look, this is how the wall is built up in the different elements, you can generate that from the database, or you explain in a short animation the work steps and what elements to be protected with what materials and so on. So this is all what is possible on the basis of your own data structure, on your own BIM database, and I'm happy to take your questions now.
Prebili smo let tudi, kar se tiče prvega predavanja, in lepo pozdravljam v naši družbi Kristjana Donata.
Welcome here from Germany. I'm glad to have this opportunity, and I'm glad that we could show the presentation not live, but with a video.
So, Mr. Thibaut, the first question for our guest from Germany would be?
Yeah, so hello and good morning. Donald, thank you very much for your very interesting presentation. It was about how manufacturers actually can integrate data in their BIM files. So the question is, how can, it's a practical one, how can actually the users of these BIM objects actually trust the data that manufacturers integrate in their files? Are there any systems in place that needs to validate the quality of those data?
Basically, the problem is in case you take the data from a manufacturer, then the manufacturer remains responsible for the data, whereas architects in other cases taking this from any database, the architects would not have the liability of the manufacturer. So I think it is absolutely favorable for users to get the data directly from the manufacturer. And in terms of quality within the application, this is the responsibility then, of course, of the one who's using the data. That's their work environment, and manufacturers should get some help properly to understand the applications for providing data which is fit for use. And this is where some experts come into play. We are supporting our clients. There are other experts out there, because you need to really understand the applications in order to decide what should be generated for download.
Hvala lepa. Thank you very much.